In Chapter 4, the entire chapter is going to be focused on quadratic functions. And today we're going to talk about quadratic functions, and everything you see today is going to be in what we call vertex form. So today is going to be easy. It will get more difficult as we continue on. Now the good news is parabolas are going to behave a lot like absolute value problems behaved, where you have a vertex to start with. So let's talk about what a parabola is. A parabola is the graph of a quadratic function. Now you might say, well, what's a quadratic function? It's something that has some type of x squared in it. And that is the next fill in the blank. Has some type of x squared in it. Now vertex form is the first thing you're going to learn about. Vertex form is a certain way of writing the equation, and it usually looks like this. It will be f of x or y equals, there will be a number, there will be a set of parentheses, the set of parentheses will be squared. You'll do x minus h and then plus k in the back. It should look very familiar to you as the absolute value ones did. The absolute value ones just had, absolute value signs. The axis of symmetry is the line that the quadratic folds around. In other words, it's like the middle line, the straight vertical line that you can fold it on. The vertex of a parabola is where the line of the symmetry and the graph intersect. Now that is the technical definition. Really, it's just the top or the bottom of the graph. Alright, that's the easier part. Take a look at this is the most basic formula of a quadratic you can get. The most basic form. The reason it's the most basic is because it's just x squared. Notice the axis of symmetry is on the origin, and the vertex is also on the origin. So it's just a U-shaped graph. Moving on. We're going to start very, very, very simple. Let's say we have f of x equals ax squared. Notice there's nothing else, where a is simply the coefficient of x squared. So here you go. If a is negative, it goes upside down. If a is bigger than 1, it gets very skinny, and that's called a vertical stretch. And if a is between 0 and 1, it gets kind of fat. Looks like it's been stepped on. That shouldn't be new to you. You should remember that. That's the same thing as absolute values. All right. Note, when there is nothing being added or subtracted, the middle point, which is called the vertex, will be 0, 0. And that's only when nothing is being added or subtracted. If I were you, if you're making flashcards as you move along, I would put that on the front of a flashcard so on the back you know what the vertex is automatically. Let's look at problem 1. What is the graph of f of x equals 1/2 x squared? See this 1/2? That means it's going to be vertically compressed. You should remember that from absolute values. Now take a look at what I encouraged you to do. Pick x's that work well with the denominator 1 squared. Plug in at least 5 x's, try to get the mirror images, plot your points. Take a look at my chart that I'm going to make. I know, because nothing's being added or subtracted, I know my vertex is going to be 0, 0 because nothing's being added or subtracted. When I make my XY chart, I like to put my vertex smack dab in the middle. Alright, so now what we need to do is we need to plug in numbers that surround 0. I'm going to pick multiples of 2, -2 and -4. I pick multiples of 2 because the denominator was 2. +2 and +4. Now we need to plug them into the equation. So we'll do 1/2 the quantity -2 squared. So that's really 1/2 times 4, which is just 2. And then we move on. 1/2 times -4 quantity squared. Well, that's like half of 16, and half of 16 is 8. Now these will be mirror images all the time, as long as you do it right. Again, half of 4 is 2. Remember that the negatives became positive because we squared them. And half of 4 squared, which is half of 16, is 8. Now I plot my points on my graph. So 0, 0 should be in the middle. I kind of like to plot that one first. Over 2, up 2. and over 4 up 8. All right, do the same thing for these negative points. Left 2, up 2. Look at that parabola coming. And then left 4, up 8. Notice it's a perfect reflection, okay? Graph your parabola. It will be a U shape, not a V shape anymore. Quadratics are a U shape, not a V shape. Okay? Notice my axis of symmetry is where the line folds, and it would be this line right here. It's the origin. You see it? So I write axis symmetry is x equals 0. Let's try this again. Got it. What is the graph of the quantity positive 2x squared? See the positive 2? That means it's going to be vertically stretched. Well, which of these graphs is vertically stretched? This one's flipped upside down. This one is not it. That's the graph of negative 2x squared, but not positive 2x squared. B is our answer. B is the graph of positive 2x squared. Now, if you made an xy chart, your xy chart would be 0, 0 in the middle because nothing's being added or subtracted. And because we don't have a denominator, you should write that down. You should pause the video, write that down. Because we don't have a denominator, I can pick my normal x's, and when I plug them in, I would simply plug them into my equation. You know, I get out my answers of 1, 2, and that would be 2 times 4, so that would be 8. And if you look here, you will see that this graph surely does match this xy chart. The got it is not only a fraction, it is also a negative. So what the negative thing is going to do is it's going to rotate it around the x-axis. So in other words, it's going to be flipped. Okay? Now what does the 1/3 do? The 1/3 is going to vertically compress it, which means it's going to look like it's been stepped on. Let's make an xy chart, please. Nothing is being added or subtracted. 0, 0 is my middle. Notice I have a denominator of 3, so I'm going to pick -3 and -6 and +3 and +6. Now I will plug them in. So this is a -1/3 times 3 quantity squared. In other words, what is -1/3 of 9? The answer is -3. Now do the same thing with 6. -1/3 of 6 squared. That's really like what's -1/3 of 36. Well, 1/3 of 36 is 12, so this is -12. As long as you did those bottom ones right, these will be a perfect reflection of the bottom. So let's plot our point. Okay, let's go left 6, down 12. Now go left 3, down 3. 0, 0 we already did. Right 3, down 3. And be careful when you count this one out. It's going to be down 12. All right. Once you get your points plotted, connect to make your U shape. And you have a perfect quadratic that has been flipped and vertically compressed. Part B. What can you say about the graph f of x equals a of x squared if a is negative? What you can say about that is that it has been rotated, let's use our real words, rotated around, excuse me, not rotated, let's reflected. Reflected around the x-axis. Okay, reflected around your x-axis. We are now going to move on, and we are going to talk about moving it left and right and up and down. Now, depending on how well you guys learned your rules of your absolute values, the rules for quadratics are exactly the same. So left and right, if you move it, you know, if it says if it's +3, you would move it to the left 3. If it's -3, you move it to the right 3. Same thing for up and down. If it's +3, you move it up. If it's -3, you move it down. Again, this will work just like it did for absolute value problems. The number associated with x gets the horizontal movement, and the number outside gets the vertical movement. The axis of symmetry is the equation of the line that we could fold the parabola around. That's not new. It's the x, here's the part, if you just remember, it's really easy though. It's the x value of your vertex. Let's take a look at problem 2. Do you see how this minus 5 is kind of just in the back? That means it's going to go down 5 when we graph it. Alright, so the transformation is that it has been translated 5 units down. The new vertex is, just like it would be for an absolute value, what is associated with x? Nothing. What's on the outside? Negative 5. So when I make my xy chart, I put 0, negative 5 right smack dab in the middle. I surround it with normal numbers because I have no fractions to worry about. And I plug those normal numbers in. So I'll do 1 squared minus 5 is negative 4. I will do 2 squared minus 5, that's 4 minus 5, is negative 1. I will then reflect these numbers up here, trusting that I did it correctly. If you don't trust yourself, plug those numbers in. You'll get the same thing. Plot your new points. So 0, negative 5 is going to be over 0, down 1, 2, 3, 4, 5. Okay, let's do the 1, negative 4, over 1, down 4, the other way as well, and then over 2, down 1. We have a perfect parabola that has simply been moved down 5 units. Let's take a look at part B. Notice on part B, the 4 is associated with the x. Because it is with the x, it's going to move left or right. Because it's a minus 4, it moves to the right 4 units. You remember that from absolute values, hopefully. So the transformations is that it has been translated to the right 4 units. The vertex will be what is with x, the opposite of what you see, a 4. What's being added or subtracted in the back? A 0, just like it would be with absolute values. Make your xy chart. Put 4, 0 in the middle. Now that you have 4, 0 in the middle, surround it with familiar points. These points look pretty different to you, don't they? That's because this is the first time you've moved something left and or right. So let's go ahead and plug in 5 and 6. So we do 5 minus 4 quantity squared. I just plug it into the equation up here. That's pretty much 1 squared, which is just 1. And then I do 6 minus 4, the quantity squared. Well, 6 minus 4 is 2. 2 squared is 4. Then I do the same thing with these. And if you don't trust yourself, you're not sure if you did these right, fix them. Otherwise, get the problem wrong. Your choice. Let's plot them. Over 4, up 0. All right. Over 5, up 1. Over 6, up 4. Over 3, up 1. And over 2, up 4. Notice the perfect parabola has just moved to the right 4 units. Let's try the got it. Which one of these will move up and down, and which one of these will move left and right? After looking at these, I hope you decide that letter A moves up 3 units. And I hope that you notice letter B, since it's associated with the x and it's a positive, moves left 1 unit. Okay, let's make an xy chart. Or actually, let's find our vertex first. That'll be the best thing to do in both the problems. The vertex in this one, you need to ask yourself, what is with x? In other words, like, if it was a parenthesis squared, what would it be? In this case, nothing. What's on the outside? A 3. So 0, 3 is my vertex. Whereas on this one, my vertex is opposite of what is associated with x, negative 1, and then what's on the outside? 0. So we'll make our xy chart on both of them. Okay, Let's put our vertex right smack dab in the middle on both of them. And let's surround them with numbers. A little smaller than 0 is -1 and -2, and a little bit bigger is 1 and 2. Do the same thing over here. A little bit smaller is -2 and -3, and a little bit bigger is 0 and 1. Let's plug in our points on part A. Let's plug in the positive ones because they're easier. So this would be 1 squared plus 3 makes 4. This would be 2 squared plus 3, which is really 4 plus 3, makes 7. If you don't trust yourself, plug them back in. You will get 4 and 7 if you plug in -1 and -2. Do I suggest that you do that? Absolutely. I just have my answer key beside me. Let's plug in 0 now into this top equation. So we do 0 plus 1, and then we square. Well, 0 plus 1 is 1, squared is 1. Okay, do the same thing. Add first. 1 plus 1 is 2, 2 squared is 4. If you don't trust yourself, plug in the other ones. You will get 1 and 4 again. Let's graph our points. Over here, we go left 2, up 7. Left 1, up 4. Over 0, up 3. Over 1, up 4. And over 2, up 7. Again, you have a perfectly shaped parabola, the U shape, not a V. You have a U-shaped graph, which is a quadratic, and it has simply been moved up 3 units. Take a look at the one on the left. -1, 0 is left 1, up 0. Over 0, up 1. Over 1, up 1, 2, 3, 4. Left 2, up 1. Left 3, up 4. 1, 2, 3, 4. 1, 2, 3. Again, you have your perfectly shaped parabola, and it has simply been moved to the left 1 unit. Now, if we ever talk about the domain values of a parabola, it's like asking what x's are we allowed to plug in. You can plug in any x. So our domain should always be -infinity to +infinity. And if you're looking at a graph, it's because it always goes to the left and because it always goes to the right. In other words, it's all real numbers. Now the range values of the parabola, that's where we get a little confused. These will either start or end with the y value of the vertex. Okay? It depends if it goes up or down. Let's take a look at problem 3. For y equals 3 times the quantity x minus 4 squared minus 2, what's the vertex, the axis of symmetry, the min and the max, and the domain and the range? Wow, there's a lot happening. Let's start easy. We have the vertex is number 1. The vertex is, why don't you try it? It should be a +4 and a -2 because it's opposite of what you see. Let's talk about the axis of symmetry, number 2. The axis of symmetry is always x equals that value right there. So x equals 4 in our problem. Number 3, is it a minimum or a maximum? Okay. Take a look at the number out front. The 3 is positive. The outside 3 is positive. You know what that means is that it opens up. Now if you're like me, you're a visual learner. There is a parabola opening up, right? Now if it opens up, what do you think? Should I have a min or a max? In other words, what's that point right there? That point right there is a minimum. So it has a minimum. That minimum value is the y value of the vertex. Y equals -2. You really should pause the video and write that down. The minimum value is the y value of the vertex. Next, we have to find the domain. Here's the easy thing. That's number 4. The domain is all real numbers. In other words, -infinity to +infinity. Because it goes on forever. The range, on the other hand, since it opens up, has a +infinity. Now, what is the lowest value? It starts at -2 and it goes up forever. Let's try got it number 3 using the exact same, just kind of reference above. You might want to try it on your own. First of all, what is the vertex of this equation? You should be saying -1, +4. Number 2, what is the axis of symmetry? X equals -1 from the x value in your vertex. Number 3, the outside number is negative. Because this outside number 2 is negative, that means it opens down. If you're a visual learner like I am, draw a parabola that opens down. So here's your vertex. Is that a minimum or a maximum? Since it's on the top, it's a maximum. The maximum is y equals this value right here, 4. In other words, it never goes higher than 4. The domain should be easy to you. -infinity to +infinity, because it goes on forever, to the left and the right. The range, this time, since it opens down, it has a -infinity, and it goes up to 4. So when it opens down, it has a -infinity. When it opens up, it has a +infinity.